Here we go with the rest of 4F. We've got a couple more examples on this page before we actually start the 4F practice. They're asking us to do a couple different things, so we'll just go ahead and look at the instructions. Graph the first 5 terms of each sequence. They give you the function, the equation right here, the function rule. So this, whoa, that's way too thick. Get the good guy here. This is a function rule, this equation right here, and they give us a table already set up. So the first term of the function rule, to find the value of the first term, we plug in and solve. So 2 minus 5 is minus 3. When n is 2, the second term would be 4 minus 5, which is minus 1. The third term would be 6 minus 5, 2 times 3, which is positive 1. Fourth term ends up being 3, and the fifth term ends up being 5. So that's easy enough. You can go over here and plot the points. Let's see, I thought I'd already done this on this graph, but apparently not. So 1, negative 3 is right there. 2, negative 1 is right there. 3, positive 1. 4, 1, 2, 3, and 5, 5 up here. So the domain, these are discrete points. So this is not a continuous. This is not a continuous graph. They ask us for the first 5 terms, and the domain is simply the x values that we used to get the y values. The range is negative 3. It's these values over here, negative 1, 1, 3, and 5. So this appears to be linear. I'm not going to connect the points because they're only asking us for the first 5 terms of the sequence. So it's discrete. We talked about that. It appears to be linear, and it's arithmetic because how do we get from each term to the next? We're adding 2. So it's arithmetic because of addition, and it's a constant change. So we can write that as well, A-R-I-T-H-M-E-T-I-C. Arithmetic, and the difference, the D, is a positive 2 from one term to the next. Okay, let's look at the next one. I'm kind of looking at this n squared. I'm thinking I'm going to have a curve coming up here if it were to be continuous. But we're going to just graph the first 5 points like they ask us to. So 1 squared minus 4 is minus 3. 2 squared minus 8 is minus 4. 3 ends up being minus 3. And please satisfy yourself that you can do this arithmetic. Don't just take my word for it. Maybe I made a mistake. Who knows? Is 5. So when we go over here to graph them, we end up with the points 1 minus 3, 1, 2, 3, 2, 1, 2, 3, 4, 3, minus 3. Whoa, that should be 2 minus 4. I was saying it, but not graphing it. 2 minus 4. So here would be the curve of my parabola if I were connecting it and making it continuous. 4, 0, right there. And the last point is 5, 5. So 5, 5. So again, this is discrete because they've asked us just to graph the first 5 points and nothing in between. The domain, simply the x's, and the range, the outputs, the y's. I'll list them from least to greatest, minus 4, minus 3, and we only have to, this occurs twice, but we only list it once. So minus 4, minus 3, 0, and 5. It is not linear, and it is discrete. So there is no difference, common difference, because when you look at how we get from here to here, that would be a minus 1. From here to here would be a plus 1. From here to here would be a plus 3, and from here to here would be a plus 5. So this is not constant change. So it's not arithmetic. So there is no D like there was in the example above. Okay, well, we'll come back together and do some more of these as a class. Hope this helped. Thanks for watching.